Alright, here we are again, my dear friends. Day number 14 in 66 days of data with KNIME, our daily live stream challenge where for 66 days in a row we cover data science topics using the amazing KNIME analytics platform from zero to hero. And today we continue our journey through section number 3 where we talk about histograms. Yesterday we learned a little bit about histograms, and today we are going to apply that knowledge into the KNIME analytics platform. By the way, while we're talking about analytics, my analytics on YouTube have shown that more than 90% of the people watching these videos are not subscribed. So if you want me to create more of this stuff to help you become more versatile in data science without being a data scientist, make sure to hit like and subscribe down below. Also, one question to you, and I repeat it also to the end again. Is that time when I stream okay for you? So right now for me it's 9:30 a.m. in Germany where I live. So just leave a comment down below with your preferred time and time zone, and let's see if I can tailor these live streams over the coming 50 days, maybe more, to your needs. With that aside, let's just jump in right in today's data. All right, here we are again. We have this data exploration in 66 days of data with KNIME page that we have seen now so often already. And as always, you can find it in the link below. It's the first link below in the description. Today, we continue to talk about mathematics. So, so no matter if you liked it or not in your school career, today, mathematics is a core of what we're going to talk. And we're also going to cover some of the topics that we have talked about previously. So we're here in section number 3, histograms. And in yesterday's lesson, we learned more about histograms, what they are. If you not have seen that, I will link yesterday's lesson up here. And today, the task is to introduce a histogram node into the workflow, build the histogram of the feature loudness for occurrences on quantile bins first and on a fixed number of bins later. Why does not it make sense to build a histogram of occurrences on quantile bins? Well, let's have a look. So, if we go here, I have now the same old workflow that we have used so often. And if we just look for a histogram here in the node repository, this is what we found. So let's just quickly select the data explorer. It holds, as we can see in the node monitor here, all the previous data. We have not deleted, we have not excluded any columns. So let's just add this and quickly give it a name, F2, histogram for loudness. And I usually make the column names bold so I know that this is, although it might sound a little bit strange sometimes in regards to what is in this comment, but I bolded, that's my own nomenclature if you want, for running KNIME and using comments on KNIME nodes. So let's just open up this buddy here. So what is the column we want to have a look at? I guess the histogram column is, as they say, loudness. So, and they said, if I got it right, they said to build occurrence count. Okay, so let's just, that's already selected. Let's just go into the binning. If you remember from yesterday's lesson, bins are basically the categories in the histogram. So let's start with sample quantiles. All right, so let's have a look. Everything else, we leave it as it is. And then we just right click, execute and open views. Takes a moment to calculate. Oh, I guess we immediately see why a quantile bin histogram is probably not a good choice, because it basically does not tell us anything. If we hover over these bars, we see that the numbers are basically the same. So why is that? let's have a look. Let's have a look at the data again. Let's look into the interactive view of the Data Explorer, and we're going to focus on the loudness. And I guess you can see it here. Once again, I'm not a data scientist, that's my interpretation, but you can see it here. So the range from the loudness is from -60 to 5.3 something positive. However, the mean is -10, and the standard deviation from that mean for 586,000 line items in this data set is only 5. So basically the majority on average, or everything, lies within -15 and -5 roundabout, if you want. So maybe that's one of the reasons, because that's why it's distributed so equally. Also, if we just have a look here, we see that our data is negatively skewed. If we let's just get back here. Yeah, I still have it open. Negatively skewed or left skewed. And we also have here, if the skewness is lower than -1 negative skewed or greater than 1 positive skewed, the data are extremely skewed. So we have a skewness here for the loudness of -1.2. So that means we have an extremely right skewed data set here. So basically, let's just close this up again. So if quantiles for equally distributed bins is not the choice, maybe we change that. Let's just go back into the histogram. And instead of sample quantiles, let's just select number of bins 5. And maybe we can up this later on. Let's just see. Okay, we keep it as it is, and let's just execute in open views again. Now this looks different. All right, it's you see that the majority, as we said, is really here in these two categories, right? We have those outliers, very few around here, but we basically have the majority in the range of -15 to -5, as we have just seen from the dataset. So let's drill down a little bit further and increase the number of bins. Let's make it 10. Execute and open views. Ah, okay, we see it even clearer now. All right. So as we said, the median was somewhere around here. The majority of the data sets lies here. We could make it even more. Let's just make it 20. Let's just see what happens. Execute and open views. All right, now we can see it even better. Right, so this is the histogram of the loudness, and it gives us a good insight where the majority of value lies. And if we just go back here and see, why does it not make sense to build a histogram of occurrences on quantile bins? Well, because it's evenly distributed. That does not make sense. That does not tell us anything. It's just 4 similar buckets. We do not get any additional insights from that. So that is the reason why we use a different approach and a fixed number of bins here. So that's it basically for today. So let's have a look at what we're going to tomorrow. Tomorrow we build more histograms for other features as well, like liveness, valence, instrument understandability, tempo, blah 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 blah. Yeah, that's basically what we will do tomorrow. Very hands-on tomorrow. So that covers today's lesson. And once again, if these live streams come at an inconvenient time for you right now, let me know in the comments down below, or if you're in the live chat for the time being, what time would be better fit your needs, what time, and preferably, as YouTube is global, your time zone maybe. And I try to adjust to the majority so we can actively participate and work on these things together. All right, that concludes today's live streaming for 66 days of data with KNIME, day number 14. I'm going to see you tomorrow where we're going to build a lot more histograms. See you tomorrow and bye-bye.